Thank you. So I'm the guy with the long beard in the picture, but short beard in reality. And I have the strangest topic. I think that maybe you don't understand what it means. And my talk will be a bit not so technical, even though I work with Scala and Spark every day working for JumpShot. We're doing a lot of big data analysis of people's behaviors on internet. And I think Ondra will later talk about more about what we do. But the talk today will be a little bit philosophical instead. It's a short talk I gave at the internal conference here at, for Avast, and talking a bit about abstractions. So even if you're not a programmer, but I hope most of you are, you'll probably get something out of this as well. And I'll start with a question. What do you think is the hardest problem in programming? Any suggestions?
Naming things.
Naming things. Any other suggestions? There are many things that are hard, and many answers to the question, like cache invalidation, or I don't know, super hard AI algorithms and a lot of big data. But this answer, naming things, comes back every time. I don't have to worry about someone mentioning it. And I'm struggling with this every day myself. I'm writing my data pipelines and my Spark jobs, trying to figure out what this thing, maybe some partial result, or just some blob of data I'm using, should be called. And some people obviously know about this difficulty, maybe others haven't, lucky you. But probably all of you are asking yourself maybe, why though? Why is naming so hard? Naming is trivial compared to the amazing algorithms I'm doing, the AI problems I'm solving, and the complex data flows I'm figuring out. But the thing is, naming is hard because a proper name imparts the essence of the thing you're naming. So let's get a little philosophical here. To understand the essence of a thing, you have to understand what role it serves, what else it interacts with. Naming means identifying concepts that matter and occasionally realizing that the thing you're working on but seem to have some problem naming maybe shouldn't exist at all. It's part of understanding what your system is doing, understanding your domain and what pertains to it and what doesn't. Basically, it's choosing the right abstraction. And abstractions are hard. It's even in the name. They're abstract. So that leads me to the topic, the search of the absconded abstraction. And I know that probably no one here is a native English speaker, and neither am I. I'm from Sweden. So let's first define this weird word I chose, absconded. So Merriam-Webster Online Dictionary says that abscond is an intransitive verb that means to depart secretly and hide oneself. And that's what I shortly want to say a few words about. In this context, I mean hidden, a secret abstraction that's somehow lost. And I also like words, so absconded sounded awesome, so why not? More concretely, I want to talk about language. And you might be familiar with the notion that language used to describe or talk about something influences how you think about it. It's called linguistic relativity. So language has actually a direct influence on understanding, reasoning, problem solving, and creativity. And in software, it's even more important because it's not just some theoretical thing about language and meaning and what does it mean, but actually software models put hard constraints on what you can do. So having a correct language can be the deciding factor between success and failure of projects. And if it has influence on creativity, it also means that it has impact on business, which is sad because we all want to earn millions in our startups. I'm also going to talk about two concepts from domain-driven design. Maybe some of you have heard about domain-driven design. It's let's say, a holistic approach to software development. Encompasses from idea to implementation to how business is going to talk about things. And it's very wide, so DDD itself, I won't mention it very much, but there are two concepts I want to talk about from there. And these well, it looks strange. These concepts are bounded context and ubiquitous language. And I know what you're thinking, ubiquitous. Why is this guy choosing so many strange words? But this is not my fault. This is Eric Evans, the creator of domain-driven design's choice. So let's see what it means. Ubiquitous is an adjective that means existing or being everywhere at the same time, constantly encountered. So it means ubiquitous language means the ever-present language. The terms and the verbs that are used to describe a domain and that are used everywhere in this certain domain. And this language is exactly defined for the particular domain. Every term has one meaning. For example, a person or a purchase might be quite a different thing in various domains. A purchase is different than if it's of a book or a dishwasher than if it's a purchase of a monthly subscription, for example. And they should probably be modeled quite differently. And this leads us to the concept of bounded context. Because the bounded context is the boundary for which one language changes for another. It's where person starts to mean something else, where person has a different software model that describes the fields. And JumpShot, this talk is a bit directed towards big data. So, and JumpShot, we're a lot of big data freaks there. So, our most big data applications that I can think of and I've seen today look something like this, which I call the data monolith. We have one huge, or maybe a few data sources with a lot of data. And this data then flows in these different pipelines you see in these arrows here. And they create some nice data artifact at the end. That's usually how it looks. And these pipelines, these arrows, might be actually completely independent pipelines or even applications. But somehow, I put them in the same white blob because they're somehow connected, and especially in the way we treat the data. In worst case, of course, there is like only one pipeline or one application that creates a lot of different artifacts, but that's bad and that should not happen, so let's hope it's not like that in the real world. But what makes them connected, though? Well, it's how we reason about the data. We usually think of the data pipelines from the beginning to the end to the different artifacts in a very similar way. Maybe there is some enriching in one pipeline, or there is some removal in another, or some joining and super many transformations. But we look at the data as an extension of the data in the data sources. How we name the fields and how we think about them depends on how they were named in our first big data table. And the problem is that one way of interpreting data is never good enough if you want to make the most out of it, not even in small data. So in software development in general, there were very similar problems. You had monolithic applications with tangled code and tangled concepts, and you had lots of problems. But software people started using microservices in the last few years, and it's something we use as standards, and I hope that most of you know about microservice architecture. And these microservices, if they're implemented well and thought through, should map one-to-one to the bounded context in your domain. But the problem is that it cannot only be a thing of technical implementation, having a new server with some new application, but it should also be a thing of mindset. We have to think about the data as the data and the data apps as different worlds. The data inside these worlds might come from the same sources, and especially in most cases it's like that. But once the data is there, the data is completely different. And if it's different, they obey different laws and are explained using different languages. And if we do things like this, we radically simplify our ability to reason about the data, because huge flows of big and wide data models is just too much for our feeble brains to wrap our heads around. We have to be exact and simple. And this is the most proper way of doing it. Now, finding out which bounded context you have or you're dealing with in a particular domain requires a lot of work. You have business working together with data science, working with engineering together to find the common language, the different languages. And it's quite complex, quite long, arduous road to find these. And I won't talk about that. But once you have these boundaries, say you've thought it through and you have these boundaries, we need to manipulate the data model so that they fit according to our ubiquitous language we've decided upon. So how can we do that in like simple terms? Well, the first obvious approach is to limit the abstraction, to only take in what has any meaning to us, what has any meaning to our bounded context. And we should also validate things before we take them in. Often in big data, we have the source data is some huge unstructured table with metadata wrapped in something, and it's very flat and very wide. So we need to put some structure into it before we can do anything. So what is a telephone number? What is a country code? Is any string valid for a country code? What country codes make sense to us? What extensions in the telephone numbers make sense to us in our bounded context? We also need to map data into the names that make sense according to our ubiquitous language we're using. My colleagues at work, they mock me because I like to rename things a lot and create a lot of problems by this. But the thing is that when you have a proper name, you don't have to worry about it. Oh, business say that say this term, that means in our language that we're using this field and this field, or they are and testing they have some other language. It creates a lot of confusion, and so we have to really think about mapping data into names that make sense to us and to everyone. Why would we have one business language and one programming language, like developer language? So in our case here, we might have, someplace else they make a distinction between first name and surname, but we just care about name, for example. So being exact in what we mean within a bounded context makes literally a whole world of a difference. Now, the other way to achieve exactness is expanding abstractions. For example, in the case of jump shot, the basic data input we have is a GDPR anonymized II strip URL, a URL, a timestamp, and an ID. And the URL itself, it's just a string of a certain format. And we need to refine this and extract information from that field so that we can make any good use of it. A URL might signify a purchase. It might signify logging into Facebook. It can tell us so much about behavior. So when we are trying to figure out what information we need in our data pipeline, we should try to be as exact as we can. If we're only interested in the top-level domain and the subdomain, why drag the whole URL with it? So, when implementing domain-driven design in code, there is a very practical principle called making implicit concepts explicit. If there is some hidden meaning or some hidden data contained in various fields, let's say, this rule says that these should be made concrete and visible. And the principle helps us to understand the what's in the house of a system. So while the URL itself contains all the information we need, just by making those fields explicit helps us increase the understanding of what we're doing. So when we sometimes, have just a URL, it might make us confused of like we have to extract or do things multiple times instead of being exact and like, top-level domain is just this format and it can never be null and etc., etc. So it makes it much easier. So just finishing up shortly. I talked about language, and it determines how we think about data. I also talked about bounded context, and these can help us make sense of data by choosing a precise language, and especially by using scoping of data. And we can refine data models by either limiting or by expanding the abstractions so that they fit the language we've chosen and decided upon. And most importantly, we need to think about the borders of where our data travels. Make these borders strict so that our data models and our language can be exact. And in this way, it will be much easier to identify flaws and also maybe find this hidden abstraction that could help us make millions in the startups we're working on. So that's all from me. So any questions? It's very philosophical.
I had one. So you were talking about the language,
Mm?
and basically JumpShot is using Scala.
Yeah.
Was it a choice because of the Spark, because of the technology, or?
Well, I think that it's mostly driven because of Spark, yeah. Why we chose to use Scala.
Like in sense of alternatives, like Clojure and functional programming,
Mm.
Java 8 and everything else, like what's the best language according you, like for expressions and so on? Like regarding expressing the domain and so on.
Well, it's like Scala is very versatile for good and bad. So sometimes I would say that that's a good thing. So you can express things, not forcing something into a function that maybe is hard to identify, but you can actually have it as an object because Scala is not a pure functional language. It's object-oriented and functional. So maybe that's a good thing. So I think the problem is not very much which language you use when it comes to making things clear. You just have to make an effort to make your thoughts clear, and then it won't be a problem of what this function is. Well, sometimes you might find that I just want to make an object out of this, or so it depends. So I don't think that technology shouldn't limit the way you make code understandable. You won't say like, I use JavaScript, so this code doesn't make sense. It's because of JavaScript, That's not a good argument.
So thank you for your speech.
Thank you.